Um, Today, I'm going to talk about circuit schematics. It's a great way to follow Chandler's presentation, cover the safety part of it, and then how you should respect electricity. I created this little intro video for you guys. Although some people may deny or beg to differ, the truth is that electronics is now very important to our existence. Electronic devices are all around us. They are part of our everyday use. There is no day that goes by that we don't use some type of electronic device. Can you think about some electronic device that you use today? Phone? That's usually the most common way. Tablet? Huh? What electronic device have you used today? iPhone. Laptop. See, everyone like computer. Can I go one day without touching something that's electronic? But we rarely do get a chance to learn about the circuits themselves, go in depth and know how they operate. In this presentation, you're going to get the chance to draw and label electronics and electrical components, schematic symbols, and first of all, like anything, there's dangerous. There should be a safety precaution. You should avoid creating short circuits by not touching with your skin to any circuit component that's live, like what Chandler said. And you should learn a lot about what you do before you get really involved. And if you do have like younger children who may try to do this, you want to supervise them. I actually created a circuit here, and I had the batteries and everything put together, but sadly my battery is dead, but it doesn't work. But this is basically what I'm going to talk about. It's just a little circuit like this, and it lights up with a switch, and it just involves a battery, a resistor, a switch, and an LED. I gave you a handout, and you can look at that, and you can follow along if you like to look at the handout or try to get your screen. With circuits, this is a component diagram that shows what's involved in creating a circuit that lights up an LED. There's a switch, an LED, which is an electronic light emitting diode, a resistor, and a battery. A schematic of this, which is the same function, is drawn with these symbols. This is a switch, this is a diode, this is a resistor, and this is a battery. That's the identical circuit to this. It's only drawn differently. And this is it, a little close up, just a little bit. And this is how a circuit operates. Here we have a battery which is just made up of cells. If you look at your little packet, you can take out, or you can look at the little cell that's in there. It looks like this. Of course, you guys know about, but maybe someone doesn't. And if you put a number of them in series, and usually there's a compartment that you place them in, you can put them in series and create a battery. So a cell comprises a battery. Here we have, usually one cell is 1.5 volts. So if you have 4, they add up to be 6 volts. So this is 4 cells, which makes a battery, and that's 6 volts. Now, with a battery, there's a positive and a negative, and the chemical reaction inside the battery creates that positive and negative force, electromotive force. On the negative side is where all the electrons exit the battery, go through the switch, go through the light-emitting diode, then the resistor, and back to the battery to complete the circuit. Notice that here, you see the switch is open. So now, the electrons cannot really cross that switch because there's no completed path for it to cross over. So no electricity will flow through that circuit. We usually say electricity is like a river that flows, it's a current. So we have to close that switch. Like you see here, it's closed. So we completed that circuit and electricity flows. I want you to pay attention. Usually, this isn't mentioned, but with this is the light-emitting diode. And notice that the arrow is actually pointing in the opposite direction of the electron flow. That's very important because if the arrow was pointing in the opposite direction, then it would not work because diodes only permit electricity in one direction. That's the reason why it's called semiconductor, because one way is a conductor, the other way it's not. And this is a resistor. Usually with electricity, the flow is so powerful that it can destroy your components. Like if this resistor was not here, it would burn the LED out, and then it wouldn't work. So we need some resistance. Everything in the circuit, the wires, this represents the wires, all these lines here that connect all the components are wires or some conductor. But we usually need a little more resistance to make sure that we don't destroy our circuit. And now we go through drawing, and I have pencils for you guys, and a blank sheet. And you guys have pencils. But please do not take the components home with you, because I actually need them, I use them. And please return the pencils also. But you can keep the handouts and the sheets. Can you draw the schematic? You don't have to draw the resistor. Can you draw this and label it? If you look at your handout, there's this identical schematic. Since this is the only resistor in the circuit, it's labeled R1. There's a sub 1 that tells you how many, or it identifies the resistor in the circuit. If you had 2 resistors, then you would name the other one R2. So that's how you keep track and locate your components. Here is just a random number, 330 ohms, but they could be any value from 0.1 ohms to mega ohms, millions of ohms. So can you, I think you guys already drew it. Okay, so now let's go on to the next one. Did you label it? Okay, this is the switch. Now there are many different types of switches. The one that I have here in the diagram is a toggle switch. A toggle switch is something that toggles back and forth, so they call it toggle switch. One way's on, one way's off. But there are many different kinds of switches. Like this switch here is made up of multiple toggle switches. See? Multiple toggle switches. In your package, there's another kind of switch. It's a push button. Some of you have a push button, not all of you. So let's move on to the battery. Can you guys look at the battery schematic on your handout, and can you draw that? Something I think that's a little funny is that this little knob side is actually negative on the schematic, whereas in the actual cell, the knobs, the short knob, I thought was also negative, but actually it's positive. So it's kind of one of those things that I think is funny. Let me know if you guys are done. Anybody still working on that? Okay. And here is the LED. This one, you can think of it as an arrow that points at the top of a T. That's the easiest way you can draw it. You can draw a T, then draw an arrow, and then draw a circle around it. And then you draw two little arrows that point away from it. That shows that light is leaving. That's what it represents. It represents photons leaving, which is light leaving the semiconductor diode, which is a light emitting diode. Because there are also other types of diodes that do not emit light. But this one emits light, so that's why we have these arrows here. And notice again that the negative is at the bottom, well, at the tip of the arrow side, and the positive is on the other side. This is called the anode, and this is called the cathode, for some of you more advanced guys who know about this. And the electrons flow from the negative to the positive, which is against the arrow. And since this is a diode, we name it D1, since it's the only diode.
2 minutes.
And is there any questions or comments? There's so much that's involved that, can you guys think of anything?
Yeah, my question is, in the component diagram in comparison to the schematic, why would you use either one?
Oh, that's actually one of the homework questions. Actually, I was on this. Let's try this. How is being able to draw a component schematic symbol help to design circuit? You don't have to use physical components to create circuits. It's easier because it's more in a uniform shape. So all you really need to change is just the specifications. Otherwise, you probably would have to draw to scale, or it would be not easy to understand. But yeah, you can also do that, but then it takes up more room.
So the schematic is better?
It allows you more flexibility in design because you can erase, or well, this is for the homework, yeah. So schematics better.